Okay, the next question is a standard form question. Okay, so this is a continuation of the first video where we talked about operations involving fractions and decimals. So number 1 and 2 has fraction and decimal questions. Okay, for standard form, you're going to move the decimal point in your number until you get a number that is 1 or more but less than 10. Okay, so our number is 132.1322. Okay, so this number is not 1 or more but less than 10, so we're going to have to move this decimal point. If I were to move it here, I would get 13.21322. It's still not 1 or more but less than 10. So I'm going to move it one more time and put it here. Okay, so the decimal point, when put here, it would be 1.321322, which is 1 or more but less than 10. Now, if I were to take the decimal point one more space to the left, then we would get 0.1321322, which is less than 1. So that couldn't work as well. Okay, the next thing you're going to do is count how many times you moved your decimal point. So we moved that 2 times. The reason why we're going to count the number of times that we move our decimal point, that is because we're going to be using it as the exponent or power when we're writing standard form. Okay, so what you're going to do, you're going to write the number you have, which is 1.32. Alright, let's keep it to like 2 decimal places. Then you're going to write times 10. So the significance of counting the number of decimal places is to tell what power you should have for this 10. Okay, the sign of your power is important as well. So we move 2 spaces to the left. The power is going to be 2. Because we moved to the left, that means our power is going to be positive. So if you move to the left, then your power is positive. If you move to the right, then your power should be negative. Okay, it says we are supposed to evaluate each of these expressions. Now, you're going to follow the BODMAS or PEMDAS rule. I prefer to say PEMDAS. And so as long as you follow this rule, then you should be okay. Okay, let's do question A. There are no parentheses or brackets here. No exponents or powers, but we do have multiplication, so we're going to do that first. Okay, remembering the rules for directed numbers, we said that when you're multiplying 2 numbers with the same sign, your product should be positive. Okay, so that is going to be positive 3. Then we can go ahead and add. And we get 5. Okay, next one, we have division and subtraction. So using the PEMDAS rule, we know that we should divide first. So we're going to divide 2 into 20, that's 10 times. Then we can go ahead and subtract. Okay, the reason why I did not look at this first is because the purpose of these parentheses is to isolate this negative 3. So it is not really isolating an operation. So we don't need to look at these pair of brackets first. Alright, so next thing we're going to do is subtract. And we know that the rules for directed numbers says that you change to add the opposite. when you're subtracting your directed numbers. Okay, so we're going to change this -3 to a +3 or just 3. And we should get 13. Okay, next question, we have -6 plus 3 minus 2. Now, when you have addition and subtraction left, you don't have to do addition before subtraction. It doesn't really matter in this case. Just ensure that you're following parentheses, exponents, multiplication or division, addition or subtraction. Okay, so I'm just going to randomly choose to add first. Okay, when we add -6 to 3, using the rules for directed numbers, you should get -3 minus 2. Then we're going to use the rule for directed numbers for subtracting. That's change to add the opposite. So I'm going to change this 2 to add -2. And that gives us -5. Okay, next question, -60 divided by -3. Now what we're going to do, just follow the PEMDAS rule. You can do multiplication or addition first. So if you have only multiplication and division left, you don't have to do it where you multiply before you add. You can choose any one first. Okay, so seeing that those are the two operations we have left, I'm just going to randomly choose to divide first. And that should give you +30 using the rules for directed numbers times -2, and you should get -60. And that is pretty much it. So just pay attention to the PEMDAS rule and the rules for directed numbers as well. Okay, let's do the substitution question. Now, this one is fairly simple. All you have to do is replace the variable or letter with its corresponding value. So we're going to get 4 squared minus, okay, whenever you have two variables beside each other, they're being multiplied. So this is going to become 3 times c is 3, or bc is the same thing as b times c. So that is why we're multiplying those two. Alright, trying to get this line straight. Okay, finally. Okay, so we have b plus a in the denominator, so that's going to be -3 plus 4. Okay, so like I said before, work out what is in the numerator and the operation that is in the denominator separately. So we're also going to follow our PEMDAS rule. Alright, so we have subtraction, we have a power here, and we have multiplication. We're going to work out the power first. So 4 squared is 16 minus, okay, now that we've worked out the power, we can go ahead and multiply. So that's going to give us -9. And in the denominator, we would get, according to our rules for directed numbers, we should get +1. Okay, let's work out what we have left. So since we're subtracting, we're going to change to add the opposite. And that -9 is going to become +9. And we're going to be left with 25 over 1. Or we can just break that down to 25. And that's pretty much it. Okay, binary operations. Now, what I like to do is line up the symbols so I can figure out what value should be given to what variable. Okay, so we can see where P would be -1 in this case for this binary operation, and 2 would be Q. Okay, all you have to do at that point is substitute the variable in your binary operation with the corresponding value. So this is going to become -1 star 2 is equal to, okay, instead of writing 3p, I'm going to write 3 times -1, so we said p is -1, minus q is 2, plus 2, and all we have to do is use PEMDAS to work out our final answer. Okay, so we should get, we're going to multiply first, so that's -3 minus 2 plus 2. And since we're only left with addition and subtraction, it doesn't matter which one we do first. Okay, so we can say -3 minus 2 is going to give us -5, and -5 plus 2 would give you -3. Okay, next question. We have a pair of brackets. Now, when you have a pair of brackets in your binary operation, you're going to work out what is in the brackets first. Okay, so after you work out what is in the brackets, you notice that we already know the value that we should get when we work out the operation in this pair of brackets. Okay, so what you're going to do after that is replace what is in brackets with the value you get. So this is going to become 3 star -3. And since this is the same question, we're going to be using the same binary operation. Okay, so what I'm going to do, I am going to write, going to have to snip out this question. Okay, so what I'm going to do, I'm going to figure out now which variable belongs to what value. And to do that, the easiest way to do that is to just line up your symbols and see which variable matches what value. Okay, so P is 3 and Q would be -3. Okay, I'm just going to write the rest of this binary operation, which is 3p minus q plus 2. And we're going to do the same thing we did before, which is to replace the variables with their corresponding values. So it's going to become 3 times. So instead of writing p, I'm going to write 3 minus q, that's -3, plus 2. Okay, you're going to get, so you're going to multiply before you add or subtract. So that's going to be 9 minus -3 plus 2. And that should give you, okay, so we only have addition or subtraction left. So we can choose any one you want to do first. I'm going to choose to subtract -3 from 9 first. And you should get 12 when you do that, plus 2, and you'll end up with 14. Okay, so that is our final answer for this question. Alright, I'm going to have to snip out this question as well and move that to our next slide. Alright, so let's do this binary operation, same process. We're going to work out what is in brackets first for this question. Okay, so let us find out 3 triangle 2. Okay, so A is going to be 3 and B is going to be 2. Okay, so wherever I see 3, I'm going to put, wherever I see A, I'm going to put 3 instead. That gives you 3 squared plus 2 times 2. So B is equal to 2. then we work out. Alright, so powers first, that gives you 9. Then we multiply, so that's going to give you 4. Then we add, and that gives you 13. Okay, just like before, I'm going to replace what is in the brackets with the value we get. So this is going to become 13 triangle 1. Okay, so since this is the same question, we're going to use the same binary operation. Okay, so same thing as before. We're going to find out which value corresponds to what variable. And I like to just line up the symbols, just like before. All right, so wherever we see A, we're going to put 13 this time. So this is going to become 13 squared plus 2b. Instead of writing b, I'm going to write 2 times 1. So b would be equal to 1. Then we work out our final value. Okay, so 13 squared would give you 169. So powers first, then you multiply. So 2 times 1 would give you 2. And last thing you're going to do is add. So you get 171 for this question. Okay, so number 5, we're supposed to solve these equations. You can use the balancing method for these equations. There's also another method called the flow diagram method, but I'm just going to stick to using the balancing method. Okay, for question A, let us say we are using the balancing method. Now, there's not a particular way for you to get rid of each number on the same side as the variable. You can choose to get rid of this 5 first or the 2 first. But I would suggest that you get rid of any constants that are on the same side as x, right? So I am going to choose to get rid of this 2 first, instead of getting rid of the 5 first. And there's a shortcut way for doing that. Now what you can do, you can just bring this number over to the other side of the equation and change the sign. Sorry, you're going to change the sign that is in front of it to the opposite sign. So the opposite of add would be subtract or minus. And we're going to write the 2 on the other side of the equation. Okay, so remember the 2 is no longer on this side. So we're going to write what we have left. 5x is equal to 12 minus 2 would give you 10. Okay, now that we have this left, we're going to figure out how we get rid of this 5. Now this 5 is a coefficient, and when you want to get rid of a coefficient using the balancing method, you're going to divide both sides of your equation by the coefficient that you want to get rid of. Okay, so we're going to end up dividing both sides of our equation by 5. Okay, so the 5 is now gone from that side, and we're going to write what we have left. So we end up with x is equal to 2. Okay, question B, this one is fairly simple, because we already know what to do when we want to get rid of a coefficient. So 20m is equal to 100. So we only have one number that we need to get rid of to get m on one side of the equation by itself, and that's 20, sorry. Okay, so we're going to just divide both sides of our equation by the coefficient that we want to get rid of. So we can go ahead and cross that out, then write what we have left. And that's basically it. Alright, so next question we have negative 40 over q is equal to 10. Okay, what you can do, you can start by getting this q out of the denominator. And one way to do that is to multiply both sides by that by the variable that is in the denominator. Okay, when you do that, you can cancel out the variable from the denominator. Okay, so we're just going to multiply both sides of the equation by this variable. Okay, so this cancels, so I'm going to cross that out. It's no longer on this side, and we end up with negative 40 is equal to 10 times q, and we know the coefficient is the number being multiplied by the variable, so we can write this as the coefficient for q. Alright, so to get rid of a coefficient, we already know what to do. We're going to divide both sides of our equation by the coefficient. Sorry. Okay, so 10 into negative 40 would be negative 4, and 10 into itself, this is now gone. That leaves us with q. So since q is on one side of the equation by itself, we have now solved our equation, and we get q is equal to negative 4. Okay, so what do you do when you have, for question D, what do you do when you have more than one term with the same variable? Now, all we have to do is get our like terms on one side of the equation.